In today's video, we're taking a look at an all-new camera from Foxeer. Now, this is called the Foxeer Micro Toothless 2, and they're releasing 3 different variants. We have a mini, a micro, and a nano. And in today's video, we're taking a look at the micro here. Now, they do have some slight variances in terms of the lenses and also input power, but I'm pretty sure the overall sensor is going to be exactly identical. Now, first of all, let's take a look at some of the things they do provide you with. Obviously, you get the camera itself with a lens cover. So in the packaging, you will receive the OSD remote, which is really nice. Also, the silicone wires required. I'll show you how to set these up in a bit. And 4 screws and some spacers, which are going to be very useful. And the instruction manual, which you might need or might not. And also some stickers if you like that stuff. Now, this antenna we'll come back to in a bit here. So first of all, this camera is not really meant for racers due to a couple things. This is not aiming for the lowest latency. It's aiming for the best low light performance. So for example, if you want to start flying when the sun starts to go down in summer, you'll be able to do that also in low light conditions, which is really great if you're looking for such thing. Also, another really great feature, it's rocking a CMOS sensor with a rolling shutter. I did see that through the latency testing, which is something you want, something really nice to have. Also, we do have the option to switch between 4:3 and 16:9 with a slight loss of field of view. And it does have 100 dBs of wide dynamic range and 3 DNR. Now, I don't know exactly what that means, but hopefully it's something good. So for input voltage, this is very interesting. It takes 4.6 to 20 volts. So keep that in mind. So if you want to give this raw battery voltage, the maximum you want to set up on this is a 4S. However, I never recommend giving any FPV camera battery voltage. Always try to go from a voltage regulator. One is they're more susceptible to noise, so you'll get weird lines in your feed if your quadcopter or your FPV wing is noisy. And it could be very annoying and ruin your whole flight experience. So always give this from a 5-volt regulator or 10 or 12-volt regulator, whatever it might be, just some sort of a stable voltage input. Now, this also does have the OSD. It has a built-in OSD with a V-Sense right here. So if we take a closer look here, we see we have V-Sense. Now, V-Sense here, which is going to be the last wire connected in, is going to go to the positive side of where your battery is connected, or on VBAT. And what that'll do is it's basically a multimeter. It'll read your battery voltage if you didn't have an on-screen display, and you can actually output that information to the camera. Now, if you're into FPV quadcopters, you really don't need that. The only people that usually tend to need that are people who are flying FPV wings with no flight controller. But it's also there if you ever wanted to set that up. So in order to install this into your quadcopter, what you really need to concentrate on are the 3 main wires, which are the white, black, and red. Those are the main wires, and you have the purple one, which is going to be the V-Sense, kind of like the multimeter that I was talking about. If you wanted to set that up, you can do that as well. And this is going to be for the on-screen display. Now, the on-screen display can also be controlled from specific flight controllers that have camera control pads. They're called CC pads or C control. It depends on what the flight controller says, but usually they're named CCs. Now, to install that, we'll come back to that in a bit here. So now let's go to the main wires, which are the most important wires here. So what we have is we have the yellow, black, red, and purple. So let's move the purple away and let's start concentrating on the black. Now, the black is going to go to any ground pad on your flight controller, and that's basically just the ground for the power. Now, the red wire is going to be the power wire. Now, that could be either 5 volts, 10 volts, 12 volts, even battery voltage up to 4S, but again, I don't recommend battery voltage. So let's just say 5 volts. So this will go on a 5-volt pad. The black wire is going on the ground, and the yellow wire is going to be on your V-in or cam pad on your flight controller. So sometimes they call it V-in, sometimes they call it cam, sometimes they call them different names, but usually it's like V-in or cam. Most of the time, that's what they call them. So that's where you'd want to set that up. So now we're set here. Now, again, this V-Sense will go to the VBAT, or it will go to where your battery is connecting into your 4-in-1 ESC, wherever you have a pad that has the raw battery voltage on it. And that's where you'd want to set that up here. Now, if you wanted to do the camera control, what you need to concentrate on is the white wire here. You're going to have to cut this off, possibly around here. And the ground wire is going to be a bit annoying, so I'd probably just cut both of them off. And I'd wrap this ground with this ground together and solder them on a ground pad. And this white wire, I would set it up on the CC pad or the camera control pad. Or if you didn't want to do that, you could just leave this as is, and then you could use the OSD remote in order to change the settings on this, like turning off the on-screen display, or just changing the name. You could do all kinds of stuff. Brightness, contrast, exposure, shutter. You can do all kinds of crazy cool things in there. 16:9 to 4:3. So that's what you'd actually use this for. So try not to ruin it if you're not going to be installing it into a camera control pad. Just leave it as is and try to wrap it somewhere nicely here. Now, in terms of dimensions, I really like Foxeer starting to go into a much thinner profile here. So if we take a look from the front of the lens to the back of the camera, it is 21 millimeters, which is something really nice. And again, this is a micro camera, so its overall width is around 19 millimeters here. I really like how fat the lens is and just the overall profile. This will, especially if you have a frame that has a lot of carbon fiber portraying by the camera area, this will keep your camera protected and reduces the chances of you actually breaking the lens and or breaking the camera. So this is really nice to see here, because I've seen some of their past ones where there's just like basically that long, like 3 cameras into one. So this is a really great transition here. Now the wires are also silicone. I love their wires because they're a weird silicone stiffness. I mean, like wherever you set them up, it's just gonna stay like that. Look at that. That's really nice. I like that. It keeps the overall build very clean. I wish more people would do that, but anyways, it's a really nice addition that I really love about Foxeer here. Now let's discuss the latency. Well, the latency is, again, this is not a racing camera. This is more of an FPV freestyle camera, or a chill camera, if I would say. The lowest latency, which is the best latency we got, was 16.5 milliseconds. So that's pretty good. Now, if you add in the HDO goggles with a rapid fire's latency, that's around 12 milliseconds. So you just add 12 milliseconds to that, and that would be roughly 28.5 milliseconds. So it's acceptable. Now, for average latency, I would say it's around 18.8 milliseconds, and the worst latency was 22.6. So it's not a stable latency. It fluctuates between 16.5 to 22.6 when an LED is turning on. So what goes on here is this is inside a box, and the LED turns on. My oscilloscope catches when it turns on, and then I'm also listening on the video signal of this, and I could see when the camera actually registers the LED turning on, and I could just calculate the difference there, and that's what you see in the pictures. So with the LED turning off, it's always a different case in all cameras. You do see an increase in latency, and this is normal. I usually go by the LED turning on personally. So with the LED turning off, so from a bright room to super dark, the best I've gotten was 32.2 milliseconds, and the worst was 36.2, and the average is 34.4 milliseconds. So it's an acceptable range with the LED turning off. I never really look at it, but I just provide this data so you can make your own decision. So overall, it's a decent camera. It's a good camera. It's nothing very bad. Now, what I would consider bad is anything above 35 milliseconds. That's where you really get to feel it. But like this is a pretty good camera. So that's something really nice. But at the end of the day, it's your decision, and everything's linked down below. If you could check those out, those are great. Support the channel, guys, and I'll see you in the next one. Peace out.